Dear students, we are discussing about laws of motion. In the last class itself, we discussed about laws, and already I told you three laws are there. How many laws are there? Three laws are there. First one is law of inertia, and in the last class itself, we discussed about law of inertia and how many types of inertias are there. We discussed, and with one example also, we discussed about law of inertia, right? Now we are going to discuss about the second law. Second law we will write here. Second law. So what we know about second law? I already told you the first one is qualitative law, second one is quantitative law. First one is qualitative, second one is quantitative. Some quantity is there. So now before going to discuss about second law, we have to understand one more word. What we have to understand? We have to understand one more word, that is momentum. That is momentum. First we will try to understand about momentum, and after that we will come again into Newton's second law. I hope you are understanding, right? We are not discussing about Newton's second law. Before Newton's second law, what we are going to discuss? We are going to discuss about momentum. Generally, we are saying that this momentum is also known as linear momentum. Which momentum it is? Linear momentum. Sir, why you are saying here momentum? Again you are saying it is linear momentum. Why? Why? Because in further classes, and momentum is broadly classified into two momentums. One is linear momentum and second one is angular momentum. What is the first one? Linear momentum, and second one is angular momentum. If you ask, sir, what is the difference between the two momentums? What is the difference between two momentums? So we know in this word itself it is what is this one here? This is a linear momentum. What is the meaning of linear? What is the meaning of linear? Linear means straight line. That means the momentum along the straight line path is called a linear momentum. Momentum in a straight line path is called linear momentum. And if you consider some angles, if a particle is rotating, if a particle is circulating, so if you are calculating the momentum, that momentum we are saying it is angular momentum. That angular momentum we will discuss in further classes, but now we will try to understand linear momentum. See, generally, if you want to see the physical significance, of linear momentum. Generally, what it will describes? What momentum says? Momentum says that the quality of motion. What momentum says? The quality of motion. Momentum says about quality of motion. Momentum says about the quality of motion. If you ask again, sir, what is the meaning of quality? What is the meaning of quality of motion? If you are asking about the quality of motion, we are saying general examples are there. For example, here one car is there, one car here is there, and it is moving with 10 meter per second. And here one car is there, same car, and it is moving with 100 meter per second. Here two cars are there. I will write this car A and car B. Car A and car B. What about car A? Car A is moving with 10 meter per second and car B is moving with 100 meter per second. For example, the two cars are moving. So while we are seeing the two cars, what we will say? How much speed it is going? Yes or no? We are saying that car B is moving with high speed. Car B is faster. Or car A moving slowly. We are saying, right? That is the meaning of quality. That is the internal meaning of momentum. Momentum defines the quality of motion. how speed it is going, or how fast it is going, or how slow it is going. How slow. So both we are saying the quality of motion. So here the physical significance of linear momentum defines the quality of motion. Quality of motion. But generally momentum is defined as defined as the product of mass and its velocity. How we will define? Repeat with respect with me. How we will define? It is defined as the product of mass and its velocity. Generally, momentum is denoted by the letter P. Momentum is denoted by the letter P. So here I will write it is denoted with letter P. So now you tell me what is momentum? Momentum is defined as the product of mass and its velocity. Mass and velocity. So momentum, I will write P is equal to mass into velocity. Mass into velocity. So I will write P is equal to M into V. Very, very important formula. Very, very important. P is equal to mass into velocity. P is equal to mv. P is equal to mv. Can you tell me what is SI unit? SI unit. What is SI unit? SI unit is mass means kg, velocity meter per second. What is the SI unit of momentum? Kg meter per second. Why? Because we know mass means kg and velocity meter per second. That's why I'm writing the SI unit of momentum is kg meter per second. What is CGS unit? CGS unit. What is CGS unit? Mass in terms of CGS, it is gram. Velocity centimeter per seconds. Gram centimeter per second. I hope you are understanding, right? What is the momentum? Momentum signifies, or momentum gives the quality of motion. Momentum gives the quality of motion. So here generally it is defined as the product of mass and its velocity. Product of mass and its velocity. Momentum is denoted by the letter P. Momentum is denoted by the letter P. P is equal to mass into velocity. Mass means m, velocity means v. So here P is equal to mv. SI unit kg meter per second. On the CGS unit it is gram centimeter per second. Clear? I hope you understood, right? Just again revise yourself. See, now we are discussing linear momentum. I hope it is clear, right? So now we know that linear momentum P is equal to mass into velocity. So try to understand, sir, why you are writing mass into velocity. You can write mv. But when I will write mv, some students are getting confused. How it is? So v means velocity, right? But you see here, this situation, here one car is there, and it is moving. And for example, mass is there. Mass, for example, I am saying that the mass of car is, for example, 500 kg. Mass of car is how much? 500 kg. So it is moving, so that initially it is moving with some velocity 30 meter per second. How much velocity is moving? 30 meter per second it is moving. And after that it is accelerated, right? So that its velocity at this point, its velocity, for example, here 50 meter per second. 50 meter per second. So in this situation, if you observe that the car has two velocities. How many velocities? Two velocities. Here one velocity is there, and here one more velocity is there. So this velocity we are calling it as initial velocity. What is this? Initial velocity. And this one we are calling it as final velocity. I hope you are understanding, right? This is initial velocity and this one is final velocity. So I will write here, the initial velocity. Can you tell me initial velocity is denoted by? Tell me, initial velocity is denoted by the letter? Correct. It is u. U is equal to 30 meter per second. And what about final velocity? V is equal to 50 meter per second. Correct. But what is momentum? Momentum is mass. It is defined as the product of mass and its velocity. But here two velocities are there. If two velocities are there, how many momentum will be there? Two momentums are there. Why? Because here it is one velocity. Mass into velocity, one momentum is there. And here one more velocity is there. That is also mass into velocity. One more momentum is there. So two momentums will be there. Correct? So the first one is called initial momentum and second one is the final momentum. Clear? I hope you are understanding, right? The first one is called initial momentum. That's why I am writing here. Therefore, initial momentum P initial. Just here, momentum is denoted by P only. I am writing here it is I. Why? Because initial momentum, that is Pi, is nothing but mass into velocity. Velocity is not V here. Velocity is U. That's why I am writing initial velocity mu. Don't think it is always V. It is the velocity at that point. So here it is Pi is equal to mass into velocity. Can be written as, what is mass here? 500 into, and velocity is 30 is given. And units we will write after. So we can write here 5 3s are 15. And 2 zeros and here 1 0. 1, 2 and 3 zeros. And what is SI unit? SI unit is kg meter per second. I hope you are understanding, right? Clear? Now calculate final velocity. Final momentum. Final momentum. See, final momentum is denoted by the letter PF. F means final. I means initial. F means final. So PF can be written as mass into velocity. Again mass into velocity. Here which velocity it is? Final velocity. So I will write mv. So m is 500 and v how much is given? 50. So here 50 can be written as 5 5s are 25 and 3 zeros are there. And kg meter per second. So in this way, depends upon the velocity, momentum also will change. Depend upon the velocity, momentum will also change. Here in this situation, the body have two momentums. Initial momentum is there and also final momentum will be there. Clear? I hope it is clear, right? Please make a note and try to understand. When I am speaking, you try to revise my words. Then it will be easy to remember. Otherwise, no need to refer books every time. Am I clear? Please note down. See this question. I hope you understood, right? You understood about what is momentum and how to calculate the momentum. Clear? Now we'll see this question. Here, in this question, it is given that, see here, a car of mass 1000 kg is moving with an initial velocity of 10 meter per second. Initial velocity is given. How much it is? 10 meter per second. And attains a final velocity of 20 meter per second. How much velocity is? 20 meter per second. He is asking that find, three questions he is asking. Find initial momentum, final momentum and change in momentum. Initial momentum, final momentum and change in momentum. Just you pause the video and try to solve within 2 minutes. I think if you are watching this video, just you pause the video. Don't see the solution. Why? Because already you know how to solve, right? You know what is momentum and how to find out the momentum, right? So pause the video and try to solve, and after that we will discuss. Am I clear? Now see. I will write solution here itself. Solution. See here, if you see a car is there, again I will draw a car of mass is how much? Mass m is equal to 1000 kg, and it is moving with initial velocity is given. How much it is? 10 meter per seconds. 10 meter per second, and attains a final velocity of 20 meter per second. Here at this point, this car is having velocity of 20 meter per second. He is asking initial momentum, final momentum, and change in momentum. So it is easy. We will see. Initial momentum is denoted by correct. That is Pi. Initial momentum. Correct. So I will write Pi is equal to mass into its initial velocity. I will write it is u. So here mass is 1000 into velocity is how much? 10. So it can be written as 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros kg meter per second. Clear? I hope everybody got the same answer. Yes. Now see second one. Final momentum. Final momentum. What is final momentum? Again mass and its final velocity. Final velocity is v. Can be written as again mass is 1000 into what is the final velocity? Final velocity is 20. So I will write 20. So I will write 2, 1, 2, 3, 4. 4 zeros. 1, 2, 3, 4 zeros. Kg meter per second. Am I clear? I got initial momentum and final momentum. But what is the third one? What is the third one? Is asking change in momentum. We will try to understand. Change in momentum. What is the meaning of change in momentum? How much it is changed. Initially something is there. Finally something is there. How much it is changed. So how to do? How to do? Yes. Change in momentum is nothing but final momentum minus initial momentum. What is change in momentum? Change in momentum is equal to final momentum minus initial momentum. So here generally change in momentum is denoted by delta P. How it will represent? It is represented by delta P. See here, delta and P. Easy only, na? Change in momentum is denoted by delta P. So here change in momentum delta P is equal to what is change in momentum? Final momentum minus initial momentum. Final momentum is Pf and initial momentum is Pi. Pf minus Pi. So here I will write what is Pf. What is Pf here? See. So I will write here final momentum. So 2 into 1, 2, 3, 4. 10 power 4 I will write. Correct? 2 into 10 power 4 is 1. Minus initial momentum. Initial momentum is 1 into 10 power 4 I will write. So I got change in momentum. So I will solve this one. So here if you see this one here also 10 power 4 is there. Here also 10 power 4 is there. So I will take 10 power 4 common. If I take 10 power 4 common, so here what we get? 2 minus 1 will be there into 10 power 4. So 2 minus 1 is 1. So 1 into 10 power 4. How much are you getting? 1 into 10 power 4 units kg meter per second. So this is the answer for change in momentum. Clear? I hope you understood, right? So what we are calculating here? What we are calculating? We are calculating momentum. How to find out the momentum. What momentum is? Momentum gives the quality of motion. How speed is going or how slow is going. So generally it is defined as the product of mass and its velocity. Mass and its velocity. So m and v. Where v is initial velocity or final velocity, what it will be? So you have to write mass and its velocity. I hope you understood, right? Clear? Please note down. Dear students, I think you understood, right? How to solve the questions based on momentum. But when we are in some Olympiad classes, or when we are in some techno classes, when we are in foundation classes, this basic questions he will not ask. He will not ask a car is moving, find initial momentum, final momentum, change in momentum. So he will ask some different questions, right? So we will try to understand in what way he can able to ask the questions. Clear? See here, for example, here we will discuss in 2-3 cases based on momentum how we will ask. See here, for example, case 1 I will write. Case 1, try to understand here. Case 1. For example, here one body is there of mass m, moving with velocity, for example, u. Mass m moving with velocity u. So here one wall is there, big wall is there, right? Big wall is there. Clear? Now just imagine it moves in this direction and collides like a ball. I'm having a ball, I throw to the wall. Then what will happen? It will hit the wall and it will come back. Yes or no? It will hit the wall and it will come back. So in this situation, for example, after hitting, it is coming back with the same velocity, for example. With the same velocity. Clear? Now he will ask, find the change in momentum. Find the change in momentum. So what he will ask? Find change in momentum. See here. Find change in momentum. We know already change in momentum is denoted by delta P. Delta P is equal to final momentum minus initial momentum. First I will write initial momentum. What is Pi here? Tell me, what is Pi? Pi is equal to mass into velocity. I will write mu. And Pf is equal to mass into velocity. I will write mu. Correct? Now students are thinking, sir, if initial momentum is mass in mu and final momentum also mu, so change in momentum. What is change in momentum? Final momentum minus initial momentum. Then is it will be 0? Is it will be 0? Say yes or no? No, it will not be 0. Why? Because, try to understand, here momentum is defined as the product of mass and velocity. So velocity is a vector quantity. Velocity is a vector quantity. So vector quantity means it depends upon the direction also. So here what I will do is, so here I am assuming this one is positive x-axis and this one is negative x-axis. Clear? Now this particle is moving towards the positive x-axis. So if it is moving towards the positive x-axis, I will write this is plus. So I will write this is plus. Now what about this one? It hits the wall and returns back. So this is moving, the return ball is moving towards the negative x-axis. So I will write this one is negative velocity. Clear? Here negative minus symbol represents its direction only. Don't get confused. It is not small value or less value or big value. Minus here represents only the direction. Why? Because velocity is a vector quantity. So in this situation here, initial momentum I got mu and final momentum I got minus mu. So delta P, nothing but Pf minus Pi. So which can be written as minus mu. Pf is how much? Minus mu. Again I will put minus here. Minus how much it is Pi? Mu. So here delta P is equal to minus of 2 mu. This will be the answer. Clear? Delta P is equal to minus 2 mu. I hope you understood, right? So we'll go with the next case. See here, next case is here I will try to explain. So here case 2 I will see. Case 2, see. Case 2. Now again here wall is there. Here wall is there, for example. Wall is there here. And here one ball is there of mass m and moving in this direction with some velocity u. Again it travels, it hits and return back and it is moving some velocity v. We don't know, right? It may be the same velocity or different velocity, depends upon situations. If you go in higher classes, in class 11, we can understand. Under what conditions the body is moving with same velocities and it is moving with different velocities? Now, there's some conditions are there. That one we'll try to understand in later classes. But here it is moving with some velocity u and it is moving with some velocity v. Again the question, find change in momentum. Find delta p. What is delta p? Change in momentum. So here I will write here delta p, initial momentum, pi. What is pi? Pi is positive or negative? It will be positive. Why? Because the particle is moving towards the x-axis, right? That's what it is, mass into velocity. Clear? And final momentum. What is final momentum? Pf. Pf is equal to minus mv. mv. Why? Because the particle is moving towards the negative x-axis. That's why I wrote here minus mv. And now change in momentum, delta p. Delta p is equal to final momentum minus initial momentum. Final momentum minus initial momentum. How much will get here? Final momentum is minus mv. Final momentum is minus mv. And initial momentum, again here minus, initial momentum is mv. So here it is, I will take minus common and m common, minus and m I am taking common. So here I will get v plus u will get. V plus u. And this is delta p. But clear this one? First case, it is moving with the same velocity, it is bouncing back with the same velocity, and here it is bouncing back with different velocities. Both are same only, and we have to apply the condition only, right? And we will see a few more conditions here. See here, case 3, case 2 completed. Now we will write case 3 here. Case 3. So now again the same ball is there of mass m, moving with some velocity u. Moving with some velocity u. And hits the wall. After hitting, the ball comes to rest. I hope you are understanding, right? Every time we should not say about this bouncing back. So there are some conditions are there. So after hitting, this ball comes to rest. It falls down, for example. Clear? So now in this situation, with what velocity is bouncing back? Zero velocity. There is no bouncing velocity. There is no final velocity here. So how to find out here? We will see here. See, is asking that find delta p. Find delta p. So here I will calculate. So initial momentum pi, which is nothing but mass into velocity. It is same as mu. And final momentum, if you write, it is mass into velocity. What is velocity here? After bouncing back, there is no velocity of the further particle, right? So the velocity of the particle is 0. So I will write it is 0. It is 0. So we can write final momentum will be 0. Final momentum is 0. So change in momentum. Delta p is equal to pf minus pi. So pf is anyway it is 0. 0 minus m. So delta p is equal to minus of m. This will be change in momentum. Change in momentum. These are conditions only. No need to worry. Sir, this many cases are there, how to solve? No need to worry. Only just I am applying initial momentum and final momentum and change in momentum formula. Else nothing is there, right? Please note down. Now we will see the last case, that is case 4. Case 4, and very important case it is. Why? Because in class 11th itself, class 11th also, there are some questions based on this case 4. So we will try to understand. For example, here one I will draw wall is there. Just I will draw wall like this. Wall this one. Correct? Up to now we discuss about ball is moving in this direction only. But in this situation, the ball is coming like this. For example, this one. Ball is this one of mass m moving to some velocity u. And hits the wall. Then after that, it reflected back. For example, with the just imagine the dotted lines, and it reflects in this direction. For example, and it is moving some velocity v. I hope you are understanding, right? I hope you are understanding. In this situation, In this situation, ball is moving in this direction and it hits and reflected back. So for example, I am saying that for our understanding purpose, for example, depends upon the question, right? We should not by heart first thing. We have to understand. Why? Because here I will write this is theta. This one is theta. Theta is the angle. But in question, sir, he will use this one is theta. Correct? But we should not by heart. We have to understand. So based on the theta only we will proceed. Based on the theta only we will proceed. So for our understanding purpose, I am writing here it is theta here. Here theta. For example, here one angle is there. Here another angle is there, right? So here I will write this is theta 1 and this one is theta 2. Two different angles are there. Why? Because it is incident with some angle and reflected back with some other angle. So what we are going to find? We are going to find change in momentum. So in this situation, how to solve? See, we have to find out the perpendicular components. So how we are solving? I know if the body is moving in this direction, so how to find out the momentum, right? So now body is moving in this direction. Now I will convert in this direction how it is moving. So we know that it is u. So here the body is there, mass m. In this direction it will be u cos theta. I think this one is clear. If not, listen again. For example, here one triangle is there. Here x coordinate is there, y coordinate. If I draw one line, just try to understand here. Again, broadly I will explain in one more video how to find out the angles. Here theta is there, na? Here theta is there. Where theta is there, that side will be cos theta. Here theta is there, right? This is theta. So this one will be cos theta will come. For example, here I am writing this is u. So this will be u cos theta. Where theta is not there, then sin theta will come. Where theta is there, it is u cos theta. Where theta is not there, it is u sin theta. Clear? Now see here, it is theta is there. Here theta is there. That's why I wrote this side. How much I wrote it is u cos theta. Body is moving in this direction. Now this one moving in this direction by making angle theta 2 here, theta 2. So in this direction, how much it is? Tell me how much? M V cos theta 2 and this is theta 1. Try to understand. In this direction, the body is moving in this direction only. Again, I modified. How I modified? If the body is moving with velocity u by making an angle theta 1, in this direction it will be u cos theta 1. And in this direction it will be u cos theta 2. So now I know in this direction how much velocity is there. So again I will write initial momentum. What is initial momentum? Mass into velocity. Which velocity? Not this velocity. We have to consider this velocity. Right? So mass into velocity. What is velocity here? U cos theta 1. And what is final momentum? PF. PF is equal to M V cos theta 2. And the particle is moving in this direction. So I will write here, minus here. He is asking change in momentum. Change in momentum is delta P. Delta P is equal to PF minus PI. So it can be written as minus M V cos theta 2 minus M U cos theta 1. So this will be the final answer. So if you want to modify, you can modify further. So here I will write here M only I can able to take common, right? So I will write better no need. M only you can take common. So here minus M, if I will write here, I will write V cos theta 1 minus of minus plus will come. So it is U cos theta 2. Like this also you can write delta P. Clear? I hope you understood, right? Clear? In this class, what we discuss about momentum. Generally, how many momentums are there? Two momentums are there. One is linear momentum and angular momentum. Angular momentum we will discuss in the further classes. So, linear momentum we discuss. Linear momentum is the product of mass and its velocity. product of mass and its velocity. So after that we discuss about initial momentum, final momentum, change in momentum and some cases. I hope you understood, right? Thank you.